Hello everyone. In this video, we'll discuss about Poisson distribution, the next theoretical probability distribution. Like binomial distribution, this is also a discrete probability distribution because it will take integer values from starting from 0, 1 to etc. But it goes till infinity instead of n, what is there in binomial. So a Poisson distribution may be obtained as a limiting case of a binomial distribution under the following conditions. First one, the number of trials is indefinitely large, means that n value, if it is very large, number of trials are very large, then you can say that n tends to infinity, okay? And then small p, that is probability of success, is indefinitely small. That means this implies that the p tends to 0 because it is indefinitely small. Means when n is tending to infinity and p is tending to 0, and then if I multiply that n value and this p value, and if I get a finite value, say lambda, this we call it as lambda, then you can approximate a binomial distribution to a Poisson distribution, right? Now, based on those three conditions, the binomial probability function for a random variable capital X tends to a Poisson distribution, and its probability mass function, this is our probability function or probability mass function, which is given as e to the power of minus lambda, lambda to the power of x by x factorial. As I told you, x takes the value, integer values 0, 1, 2, and so on up to infinity. Here, x is considered to be the number of successes or occurrences of the event. Lambda is nothing but n into p, and this e value is 2.718 and so on. It is an indefinite value, means never-ending value, 2.718 dot, 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 dot. And this Poisson distribution is an uni-parametric distribution, means it has got only a single parameter, and that parameter is nothing but lambda. What are the properties of Poisson distribution? One property is that if I add all the probabilities after substituting the values of 0, 1, 2, and so on, I mean, I should have written here, I'm sorry, this should be infinity. I mean, you keep on substitute, then that summation will lead to 1, means the sum of all the probabilities should lead to 1. The second property is if there are different random variables, let us say x1, x2, and so on up to xn, are different Poisson random. Everything follows Poisson with parameters, let us say lambda 1, lambda 2, lambda n. Then sum of all these random variables will follow a Poisson distribution with the parameters 1, lambda 1 plus lambda 2, and so on up to lambda n. In a Poisson distribution, mean will always be equal to variance, and that will be equal to that uni-parameter, which is that lambda. Then the next property is, for a Poisson distribution, mode is the largest integer contained in lambda. When lambda is a non-integer, and that will be equal to lambda and lambda minus 1, means it will become bimodal if lambda is an integer. So these are the properties of Poisson distribution. Now let us see, based on the last property, we'll try to do one numerical problem in the next slide. It says standard deviation is 2 in a Poisson distribution. Means we have the variance. We know the variance of a Poisson distribution is the same as the mean, and it is given by lambda. Here they gave us standard deviation. Here they gave us a standard deviation, which means square root of lambda is given as 2, which means from here I can say the variance should be square of this 2, which is 4. Now this is an integer. This is an integer, which means how mode will be done. If it is an integer, in the property it says that if it is an integer, if lambda is an integer, then the mode will be lambda as well as lambda minus 1. That means here mode equal to lambda, which is 4, and lambda minus 1, which will be, that means it is a bimodal I mean, there are two modes for that particular data. It is from a bimodal data. The data is a bimodal data. It has got two different modal values. That is what it means. So if you find this contents of this video to be useful to you, I request you to please like, share, and subscribe to my channel. Thank you. Please take care. Bye.